Hello everyone, welcome to the video. Today we are going to solve the problem anagram. In this problem, we are given two strings and we have to check whether the two strings are anagrams of each other or not. If they are, we have to return true. If they are not, we have to return false. This problem is a very easy problem, but it introduces some common concepts that we will use in solving multiple problems. One of them is storing frequencies of characters appearing in a string. So we will solve this problem today. We won't directly jump to the solution, but we will go through the thinking process and reach the solution. We discuss the questions of data structures and algorithms on this channel in simplest words with fundamental approach. If you are new to this channel, please subscribe. Let's start. To begin with, let us first note down the key things given in the question. We are given a string A, a string B, and both these strings are in lowercase letters. We need to check if these two are anagrams of each other. For example, consider these two strings, geeks for geeks and for geeks geeks. These two strings are anagrams of each other. Why? Because same characters appear in these two strings, and also the frequency of appearance of every character is same. For example, G here appears twice and even in this string appears twice. That is why we return true. So if we consider our solution as a black box, we are getting two strings as input and we are returning a boolean as an output. So what will our function signature look like? Our function signature will look something like this. Before solving the problem, let us first understand what is an anagram. For two strings to be anagram of each other, two conditions need to be satisfied. Both the strings should have same characters and the frequency of every character should be same. For example, these three strings are anagrams of each other. Why? Because in these three strings, A appears thrice and B appears once. So same characters and same frequency. Now let us think about our original problem. How do we check if the two strings are anagrams of each other? Now with these properties that the characters should be same and frequencies should be same, can we not say that if we sort each of these strings, they will all result in same string? All of these will convert to this AAAB. This is a very common observation that if the two strings are anagram, we can sort them and that will result in the same string. This can be used in multiple problems relating to anagram. Now with this observation, what will our approach look like? We'll first sort string A, then we'll sort string B, and then we'll compare them. If these two are same, then that means they were anagrams. If they are not, that means they were not anagrams. Now what will be the time complexity of this? Time complexity will be big O of mod A log mod A plus big O of mod B log mod B. Why? Because sorting takes big O of n log n time. Similarly, what will be the space complexity? Space complexity will be big O of mod A plus big O of mod B. Why this? Because we are storing the two strings, the two sorted strings in some variable, so which will take this much space. But is this efficient? No. Why? Because we have to only compare whether the two strings have same characters and same frequency, while we are spending the cost of sorting the strings A and B both. So therefore we can definitely do something better. Let us think about our problem in this manner. We have the first string. For the first string, we know what are the characters present. We also know what is the frequency of each of these characters. So what we have to do is that first we note down the characters and the frequency from first string, and then we verify that in the second string the same characters and same frequency is there. So this is what our rough approach looks like. Now let's focus on the first part. How do we note down the characters and frequencies? What do we have to note down? We have to note down something like this, that G appears twice, E appears 4 times, and so on. And once we have noted these down, in the second step, we'll again have to look for them. And how will we look? We will look by character. For example, hey, whether G is present or what is its frequency and so on. So what data structure suits this use case best? It is map. Because map has big O of 1 time complexity for storing, retrieving, by a key. This is a very common technique of storing characters and their frequencies in a map that is used in multiple problems. Now let us focus on the second part of our approach, where we have to verify that the second string also contains the same characters and same frequencies as the first string. So here is our second string. So what will we do? We will definitely have to iterate over this string. Now, in every iteration, what will we have? We'll have a current character. Now, this current character can either be present in the map or it may not be present in the map. Let's say it is not present in the map. If it is not present, can we not say that the two strings are not anagrams? Why? Because second string contains a character that first string does not. So in this case, these two strings are definitely not anagrams. Now let us take the case of that the character is present. Let us take an example. Let's say we encountered this first E. Now we know that E comes 4 times in the first string. But here we have just seen the first E so far. So what should we do when we find a character that is present? One way is we can make another map, and in another map we can similarly store the characters and frequencies for the second string, and then we could just compare the two maps at the end. But that would take another storage space of another map. So can we do something with this only? We can do something, right? When we encountered the first E, we need to mark that we have encountered one E. Now we need to see if there are 3 more E's. So we could just simply reduce the frequency here from 4 to 3. And similarly, when we see the second E, we'll reduce it to 2 and so on. So at the end of all iterations, what should we have? This map should have all the frequencies of all the characters become 0. Why do we say so? Because if E has appeared 4 times even in the second string, then this frequency would have reduced to 0 as we strike down with every E we see. And similarly for other characters. If even for a single character frequency is anything but 0, that means there is a mismatch in the frequency, and therefore the two strings are not anagrams. So what will our final algorithm look like? We'll iterate over the first string and we'll put the frequencies of characters in the map. In every iteration we'll have a character, and if we have not seen that character before, that is we are seeing it for the first time, we will put it in map with the frequency of 1. And if we have seen this character before, it is a repetition, then we will for the same character just increment the current frequency by 1. Then in the second step we will iterate over the second string. With every iteration, if it is an unknown character, that means they cannot be anagrams and we return false. While if it is a known character, we reduce frequency from the map. And once we are done with all the iterations, we have to check that in the map all the frequencies have now become 0. What is the time complexity of this approach? It will be big O of mod A plus mod B. Why? Because we have to iterate over the two strings. And space complexity will be big O of distinct number of characters in the first string. Let us now walk through the code for the same algorithm that we just discussed. You can also find the link to this code in the description. So first of all, we declare a map. What is the map's key and value type? Map is of type character comma integer, because the character will be the key and integer that will hold the frequencies will be the value. Then we first fill the map. So we pass that map and the string A into our new function. Now what does this function do? It iterates over the string A. In every iteration we have the character, and then we first check that if this character is already present in the map. If it is not, that means we have seen this character for the first time. So in that case we put that character in the map with frequency 1. And if it is already present, then we get the current frequency from the map for the same character, and then we increment the frequency for this character. So once we have filled the map in this manner, we iterate over the second string. In the second string we again have the character in every iteration. Now we first check if this character is contained in the map or not. If the map does not contain this character at all, that means we have to return false. But if the map does contain this character, then we get the current frequency and we basically reduce this frequency by 1. Finally, at the end of all iterations, we have to check if the map is now empty or all the frequencies are 0. So we pass map to this function and here we iterate over the map. So how do we do that? We iterate over map's key set. What is the type of keys? Character. So in every iteration we get the character, and for every character we check that if this frequency is not 0, then we return false. And if we in all iterations we did not return false, that means frequencies were 0 for all the characters. So we return true. This way, this is also a modular code of the checking whether the two strings are anagrams or not. Let us now summarize what all we did. First of all, we understood the problem with the help of an example. Then we thought about what is an anagram. We realized that the two strings will be anagrams if both of them have the same characters and all characters have the same frequency of appearance. So we've thought about the simplest approach to solve this. We could sort both the strings and we could compare. Both of them should be same if they have same characters with same frequency. We realized it had the high time complexity of big O of mod A log mod A plus big O of mod B log mod B. So we realized that this was inefficient as well because we really did not need to sort. We only need to compare if the same characters and appear with the same frequency in both the strings. So we thought about second approach. We stored these characters and frequencies from the first string in a map. This is also a very common approach that will be used in multiple problems. Once we had this map, we iterated over the second string, and for every character that we encountered, we kept reducing the frequency from this map. We wrote the algorithm for it and then did a code walkthrough for this. This is it for this video. For the next video, we'll meet again with some other problem. Thanks for watching.